So today's lesson would be understanding balanced versus unbalanced forces. So to recap, the definition of a force is a push and pull on an object, or more specifically, it's the interaction that causes an object with a mass to change its speed. And a change in speed means the object or person is accelerating. Also with force, it is a vector, which means we will look at the number or magnitude, but we also have to look at the direction of the force. So recap on the four basic forces that you've seen already. We have applied, friction, gravity, and normal force. Reviewing free body diagrams, this is how we illustrate or a picture of the forces that are acting on the object. You have your applied force, which is normally to the right. Friction is the opposite of applied. We have gravity that is down, and then normal force, which is upward and is usually the opposite of gravity, especially because the object is on a flat surface. So balance versus unbalanced. These are the words that you have seen before. So when we see something that's balanced, that's equal. And if it's unbalanced, it's not equal. Another term that you will see is net force. And that's just us adding the forces that are acting on the object. All right, so we have four free body diagrams. We're going to look at A and B together, and then you would do C and D on your own. Okay, so when we're looking to see if the forces are balanced or unbalanced, we have to look at them horizontally, which is left and right, and then we also have to look at them vertically, which is the up and down. So horizontally, I like to start there first. To the left, we have 20 newtons, and I'll put negative because we know left is a negative direction. To the right, we also have 20, but in this case, it's positive. So horizontally, our forces are balanced because we have 20 to the left and 20 to the right. For net force, we're going to add them. So 20 plus the negative 20 equals 0 newtons. So we should not see any movement to the left or to the right because these forces are balanced. Vertically, we have 25 newtons up, and then we have negative 25 newtons down. Once again, we have the same number vertically, it's just different directions. So these forces are also balanced in this direction. And then when we add them, we get 0. So if you're catching on to the pattern, balanced forces will give you a 0 net force. Okay. Now let's look at B. B, we have negative 15 to the left, and then we have 20 to the right. Now, as we can see, we have different numbers. So therefore, we are not balanced. Okay. To calculate the net force, we're going to add 20 plus a negative 15 will give me 5 newtons. And as you see, I have 5 newtons to the right. How do I know it's going to the right? Well, which one is the bigger force? The biggest force in the horizontal is the 20 newtons to the right. Vertically, we have 25 up and 25 down. Boom, those two forces are balanced because they are the same. So when we add them, we will have 0, and we shouldn't see any movement up and down. But since we do have an unbalanced force horizontally, you see that our object should move to the right. So now you will go and do C and D. Once you finish watching this video, you will go and do C and D, and we will come back and check our answers.